Hello everyone, my name is Bo-Xi Yu. Today I will give the talk on the automated testing of image captioning systems. The image captioning systems have many applications in the real world. For example, it can be used for remote sensing image caption. These are three examples from our case. We can also use the image captioning systems to automatically tag the photos. Then we can share the photos with the description on the social media. Image captioning systems can also help visually impaired people to understand the surroundings. For example, when a car or bus is in front of a person, the systems can tell them to pay attention to the car to avoid dangerous cases. There are some modern image captioning systems. For example, the Microsoft Azure Cognitive Services, the IBM Max Image Caption Generator, the VINVL, and the OSCAR. I will first give you a typical caption error to know about the IC errors. For example, there is a bird sitting on a bench. However, when we use the Microsoft Azure Cognitive Services, we get a caption that a person in a garment sitting on a bench. It is hilarious that the bird is captioned as a person in a garment. There are some other news that the image captioning systems failed. The first picture, it let you know that it is a squirrel, but we know that this is another kind of animal. And the second image tell you that Michelle Obama is a cell phone. I think that it is disrespectful and there's big bugs in the captioning system. There are some bad effects caused by the captioning error. For visually impaired people, this may cause threat to safety. For people who use it to tag the images, they may get bad experience. And for engineers who use it for remote sensing image caption, they may get the erroneous information and get the wrong guidance. So how many captioning errors do we find by MedIC? Using 1,000 seed images, we found 17,380 erroneous captions in Microsoft Azure Cognitive Services and several image captioning systems. The core idea of MedIC is that the object names should exhibit directional changes after object insertion. For example, the original image, a zebra standing in the field, when we insert a cat, the inserted cat should be captioned properly in the caption for the synthesized image. And to give a more comprehensive testing of the image captioning system, we use different overlapping ratios. For example, 0% and 15% overlapping ratio, and 30% and 45%. This is the overview framework of MedIC. Firstly, we have the object source images. Then we use the objects extraction model to extract the objects from the source images, and then we construct the object pool. We randomly select the object images from the object pool. At the same time, we randomly select the background images. After we get the object images and the background images, we do the object resizing and location tuning of the object images. And then we paste the object images on the background images to generate the synthesized images. The background image and the synthesized images construct a pair. We then collect the captions of the pair and get the caption pair. The caption pair is used for error detection. In MedIC, we use post tag to get the object classes of the caption sentences and use a dict to record the singular plural form of the object classes. This is an essential procedure for us to turn the natural language into the categories. We can then check the metamorphic relations and report the suspicious issues. There are some challenges in this task. The first one is the object resizing. With object resizing, we can get a relatively natural image. However, if we do not control the size of the inserted object, we may get a very big cat that in this case it blocks the area of the giraffe. Location tuning is also important. It is an essential technique to control the overlapping ratios. There's an example that the dog has been totally blocked without location tuning. Another challenge is the difficulty to verify the correctness of the captions. For example, when we use deep tests to add brightness to the images, we get an almost the same synthesized image. And the difference between the new caption and the old one is an additional A. These two captions are both right. So how naive comparison strategy gives false positive? It naively compares the words of the two captions and reports errors if they are not the same. The reason why naive comparison failed is that an image may have multiple correct caption sentences. For example, in this case, the 5 caption sentences are all right. MetaIC used post tagging to solve the test oracle problem. However, the naive comparison compared the words in the caption sentences one by one during the metamorphic relation checking. Well, MetaIC compares the key objects in the caption sentences with post tagging. There are several captioning error types. The first one is wrong singular plural form, where the single cow is captioned as 2 cows. The second error type is misclassifying the object, where the bird is captioned as a person in a garment. Another error type is omission of the object, where the sheep has been ignored. We use precision to evaluate the performance of our testing system. This table shows the comparison of part of the deep test and MetaIC on 2 models, where we can see that MetaIC can report more erroneous issues with much higher precision than the WinVL ledge. And this is the whole precision table where we can see that MetaIC outperforms deep test in the task. Then we conduct a case study on IC errors via the visualization experiment. We list the input image and attention image here. The attention image is correct for the background image. We can see that the attention image shows that there is a bear in the image. However, when we insert a black horse into the image, the attention image gives some mistakes. That the horse has been captioned as a bear. And when we change the overlapping ratio, we found that the bear and the horse are captioned as the bear and bear. And when we continue to increase the overlapping ratio, we get to find that the horse and the bear have been captioned as 2 black sheep in the image. And when we choose the highest overlapping ratio, we found that the caption becomes a couple of black horses grazing in the field. So that we can see that after the insertion of the black horse, the attention image gives different kinds of mistakes, so that it may be the clues that we get to find the root cause of the IC errors. Then we do the case study on the detection component of the OSCAR model. We can see that when we insert a giraffe into the background image of two horses, the bounding box for the giraffes takes the places of match area of the horse, so that the caption become a couple of giraffes and a horse walking in the field. The inaccurate bounding box may refers to the erroneous captions of two giraffes. We also do the case study on the language component of OSCAR. In this case, the ball on the frisbee has been accurately detected. However, the caption still cannot caption the ball properly. Therefore, it may be the fault of the language model of the OSCAR. MetaIC can even be adopted to find labeling errors in the training corpus. The core idea is that what doesn't change during the metamorphic procedure should be the important feature of the image. Thus, they should appear in ground truth labels. For example, the original image is a zebra standing in the field in the Coco caption dataset, where we insert a cat and the caption becomes a zebra standing in the field with a cat. The description of the zebra is the essential part in the image pairs, so that this kind of description should at least appear in the labeling in Coco caption dataset. By using MetaIC, we find 151 label errors in only 6,662 caption images in Coco caption dataset. Here, I will show you some examples of the label errors in Coco caption dataset. An ant licking its lips in a pantry. We can see that the first picture, there must be a typo. And the second picture, it is hilarious that it describes the dog as a man. And the third image, it must be another typo, that a dick must be a dog. And the fourth type of errors, I think that it may be due to the internet glitches, so that the person who tagged the images cannot see the images from the internet, so that it gives the caption like this. And the fifth and the sixth label errors is that the people who tag the images, they misclassify the object in the image. So that the MetaIC can be utilized to do another work except for testing the image captioning systems. And we think that by cleaning the Coco caption dataset, we can further improve the performance of the image captioning systems and other related works. Thank you for listening.